recording, and I'll share my screen. Take this one. All right, y'all see that? Yeah. Cool.
I can explain what's the issue.
Okay.
So the issue is simple. In Tendermint, we have this mode called create empty blocks. So basically, by default, Tendermint will produce blocks every second. But we also have a flag called create empty blocks, and if you set it to false, Tendermint will wait for transactions, some transactions to appear in a mempool. And when transactions arrive, like either from peers or from RPC, like somebody calling an HTTP endpoint, the mempool will ping consensus reactor saying hey, I have new transactions. And it appears that in this mode, we weren't waiting for timeout commit because this because in the implementation of this ping mechanism was just calling a inter-new round function, which basically instructs Tendermint to start a new round, or basically the process of creating a new block. And yeah, so what I did is I added if condition, which checks if the time commit had already passed. If not, it schedules a timeout. If we're already past the timeout commit, then it jumps into the new round immediately. And there is also a special condition for SkipTimeoutCommit, which is another config parameter.
So can we back off a bit? So in the description you say create empty blocks, and that's in the config 2ml, right? That we use that name, create empty blocks, and we set it to false. And how is that related? Or is that, you just mentioned something, but I want to clarify this. Let me see. Skip timeout commit, cs.config.skip timeout commit.
They shouldn't be related.
Yeah.
But it turns out there's some relation where basically it seems when we have create empty blocks set to false, Tendermint is not waiting the timeout commit. Is that right?
Correct.
Right. And that is right.
But I don't understand if the create empty blocks is set to false, that means we should not create blocks if we don't have transactions.
Right.
And why do we wait for a timeout commit?
So the timeout commit is basically the time we wait at the end of a block after we've seen a commit before we go to the next type. And the reason we wait is to give other validators a chance to submit their signature. So maybe we've seen signatures from plus 2/3 of the validator set, but then we wait a little longer to see from the rest of them, so that the next proposer, when he goes to the next round, can include, more than 2/3 of the signatures, with the goal of having all of them, because that's represented at the state machine to potentially used for rewards. So for instance, in the Cosmos Hub, there's additional rewards for including more than 2/3 of the signatures, right? So that there's some incentive for all of the votes to be included. And so that's the point of the timeout commit, because otherwise, as soon as you see 2/3, you would go to the next round, you'd go to the next height, and then, you may, those other validators, they might still be online, they might still be voting, but you wouldn't include their signatures in the block. So this is a way of just waiting a little longer to make sure you collect their signatures. But it seems like there's this unexpected interplay between that setting and the create empty blocks, where if create empty blocks is set to false, then as soon as we create the block, as soon as we receive transactions, we go to the next height rather than waiting. And I guess that's some kind of concurrency issue in the consensus state. Because so what's supposed to happen is, actually, maybe I should share my my terminal here just a second.
Because I'm kind of surprised with the fix that he doesn't want us from starting next height, but trying to sort of while we're already in the next height, more or less kind of slow us down. Normally, like if timeout. This timeout is not 0, we should not even move to the next height before it expired. So the create empty block should only matters when we are in the next height.
That's right. But I think what's happening, so sorry, I'm just trying to share my different screen here.
But yeah, I think that when we commit the block, we don't. I mean, there was a check, I think.
You can see this, right? Whatever. Okay. So I think there's a couple places. There's basically 2 places where we check the skip timeout commit and where we otherwise wait. So there's this parameter that lets us just skip the timeout commit. You can configure it to just not wait if you want. But otherwise, what will happen is in enter commit, I believe. So basically here we are in add vote. So this is like this big mega function that determines if and how we make a state transition after adding a new vote. So not every vote we add adds. Is that a cat, Anton? Cool. Sorry. So it's not the case so sometimes we add a vote and it just gets added into the pool and doesn't cause us to change the state. We've just seen a new vote, and sometimes that new vote triggers a threshold, and then we move the consensus forward. And so at the point where we add a vote, and so here for pre-commit votes, and here basically we've seen 2/3 majority, and it's block. So now we can actually commit the block. So if we go to that, we see all this. So this actually runs the commit, checks everything, and then there should be in here, I think we should schedule the timeout eventually. So this will actually go and finalize the commit. So this is the logic to actually execute the thing. It does a bunch of sanity checks, actually applies the block. So this is where it calls the ABCI app. And then at the end, it schedules the round. And this should be based on that timeout. Let's see. Yeah, so where is that even used?
Can you check the schedule round? Because in schedule round, maybe we are taking into account the value of the timeout commit.
In schedule round, wasn't that just where I was?
Yeah, because there is normally there should be like a diff between timeout. Yeah, there, but we don't do this. What is
No, because we're looking for a
start time, but we remove start time minus
yes.
And start
this happens in update. Yeah, exactly. So basically, what's happening is so I'll take that back. So the end of finalize. So this is kind of convoluted, but let's just go for you. So here's finalize commit. This is the last thing we do when we're executing a block. And then at the end of this, we call update state, which actually mutates the consensus state to say, okay, now everything's ready. We're done. It's time to update this thing. So if we go and update that thing, then it does a bunch more sanity checks. And then here we actually go and reset all the values of the internal consensus state, right? So this is where everything gets reset so that we can run the next height, basically. And over here, we reset the start time. And specifically, we set the new, so this is the start time for the next height, right? And so here we're actually setting the start time to whatever the current time is, plus the, whatever the commit time is, plus the timeout commit, right? So this config commit function actually adds the time you pass in to the timeout commit, right? And so that start time, that's how we actually configure the weighting. And then when we go to schedule, schedule new round, no, schedule round 0, I think.
Yeah, schedule round 0.
So here, yeah, so we did the update to state, we reset the start time, and then we schedule around 0. And then schedule around 0 basically schedules a timeout to run, after the start time. Between now and the start time, we sleep for that long, and then we'll go into the new round, right?
Yeah, but the problem here is that the height is already set to the new value, and so this handled transaction which runs in parallel.
Exactly. So there's concurrency at play here, right? Because this is now running in the background. This is scheduling. This schedules a timeout. So this is going to create some ticker that's going to go off in the future. That's going to restart things, right? There's a bunch of abstraction in here, but anyway. And so then the problem is when we then concurrently receive a transaction from the mempool, we immediately go forward. And so the timeout that we had scheduled no longer applies, and we're just like immediately going to the next height. And so the fix here that, oops.
So wait, so then the issue maybe is not as noticeable with create empty blocks true, but it should also show up there, right? I mean, no matter how you configure this.
No, because this handle TX is available thing only applies in the empty blocks false case.
Ah, okay.
Right, like we only, so that's that's another thing that's kind of hard to see. You actually wouldn't see it here, right? It's just a matter of if this is ever going to trigger. I think this is an interface, right? And this is only going to be basically non-nil if. Let's see, where does this get passed in? This should only be non-nil if yeah, so we pass in the mempool, and so the mempool exposes this TX is available thing, but it only does anything if, where is it? I think it's in here. This channel is only created if that config option is on. How do we see that more clearly? Let's see. Blocks. Yeah, so I don't think this is even used. think it's just in the yeah, right. This will actually do the enablement, and otherwise that channel the consensus is waiting on will never fire. So that's it.
This is another config parameter. Is system fee.
Well, this is basically based on the create empty blocks
Okay.
being false. This wait for transactions thing, right?
Okay. Yeah.
So is the race condition between the timeout and the other thing?
Yeah, and the transaction becoming available. Yeah, that's right.
Yeah.
So because that timeout is scheduled in the background, and then this transaction comes in, and you can see the transaction, this thing grabs the lock, right? And so this can happen basically concurrently, and will then, regardless of what else might be going on in the consensus state, this is saying this is just going forward, right?
Right.
The question is, should we enable this logic for handle transaction available before the timeout commit expire? Because like here, it seems that we changed the consensus state to new height, and we set all variables there, and essentially it's like it's not really enabled until timeout expire. And then, but immediately when we started this process, we enable this logic for handling transaction.
Yeah.
So like the question is, do we want to essentially postpone setting the state, or at least postpone this logic of handle TX available until timeout is?
Well, I think so. So basically, what Anton did is added a bunch of logic into the handle TX is available to postpone, and so I think. Okay, so that's if we're skipping, and that's not. And so if the start time isn't ready yet, then we schedule timeout. I'm not sure we need both of these, right? Shouldn't we just schedule around here again? Or we could just do nothing, right? Because the scheduling will take care of itself.
But you already have timeout scheduled, so
yeah, exactly.
Why scheduling another time the same time?
I'm not sure we need to.
I think we need, because if you look at the default like timeout, how we handle it, then you'll see that there is like a if check. Yeah. Я работаю. There's a default check that
someone has an opinion there.
Yeah.
There's a default check that so basically what we do is we check if there's a create empty block setting, and we won't go into the new round if create empty blocks is true. That's why we need to schedule another timeout, I think.
Yeah, no, this is definitely what you did is valid option. I'm just wondering if we can somehow simplify it a bit by not allowing this logic to run even while timeout hasn't expired. And so this essentially would be checking. So this logic where we enable this. Bucky, can you show where we enable? Yeah, exactly this handle TX available.
Sorry, what do you want?
Where we enable this guy TX available.
Oh, it's enabled up front in the mempool. So it's enabled when the mempool is created.
Mm-hmm.
Now we could say we won't read off of it. You know, we could have an if statement here, and then a different select, so that we only select over this if we've already moved into if the timeout has already expired. But that seems maybe more complicated.
But is it a better solution? Because otherwise you have another timeout and you rely on the fact that kind of you have these events, synchronizing somehow. It's kind of a synchronization what they're trying to do now, right?
Yeah.
And that's a bit, a bit suspicious, because then again the scheduler decides who comes first.
Yeah, because if you keep receiving transactions here, actually, I think this only happens once per block, right?
Yeah, it's one per block.
Yeah.
Yeah, so it won't keep triggering, but it will trigger another. So basically, I don't think we would need this scheduled timeout because this is already coming. We might need this one, but we would need to make sure it comes after the originally scheduled new height. Because basically, once the new height is received, let's see. So, you know, in handle timeout, so here, I'll show you the main routine is this guy. This is the receive routine, right? So this is basically the main routine of the consensus state. And so, you know, it receives, you know, has a bunch of different inputs. So one is that transactions available. One is messages from peers. One is internal messages, like votes that we sent ourselves. And the other is timeouts, right? So we receive a timeout. Say we received the new height and it came from, oops. Oh. My pen freaks out. Okay, so we received the new timeout, and then so we go to enter new round. But what is your problem? But if we're waiting for transactions, so if then we might not do anything, right? So we received the new height, and then this happened, and then, you know, so basically another thing we could do is like have more mutable state, and in handle TX is available, we could have, you know, we could set some Boolean to true, and then over here we could check if that thing was set to true, then we could enter the round because we've already received transactions while we were waiting for the round to start, right? And then we wouldn't need to schedule a new timeout. We would just have this additional mutable state.
And how hard is...
So, but what if we haven't received any transactions?
If we haven't received any transactions, then we would just do the normal stuff here. Like basically we would have...
But if we haven't received any transactions, like this timeout, the first timeout will still fire, right?
Yeah. So then we would go here. We would go if wait for TX, and we would say like if CS dot like received TX while
right
in
and
timeout commit.
If this is false, then we won't do anything, right?
Yeah, then we would do this. Yeah, exactly.
But it means that in handle transactions available, we'll still need to enter new round, right? Like when we actually receive transactions.
Yes.
I'm not talking about like schedule timeout, but if we like.
No, I understand. You still need to do this. Yeah. So this needs to check actually what step we're in. So this needs to be like, if we haven't entered the, you know, if we're still waiting timeout commit, then set some Boolean to true, right? Otherwise, enter the round.
Yeah. But how hard would be to not even schedule this, call this schedule round 0 before timeout commit expire? So essentially postpone everything, even like changing the consensus state before timeout commit expire. What are the
you will have some kind of postponed update, right? And things can happen before the timeout again.
Yeah, it's part of the problem is that we are let's say we have the consensus state which is partially correct. because we update the stuff and then we are we say, okay, we update.
We're actually not ready. Yeah.
We are not ready, exactly. So we had these kind of issues at several places in the code where essentially we more or less modify the state and say, okay, state is modified, but we're not really ready. And then we start introducing this concurrency, stuff which always ends up with this kind of bugs.
For sure. I mean, ultimately what we want is a better kind of state machine based approach that's like, depending on what state you're in determines, what you can do next, basically. We don't really have that. We just have this like kind of event driven, regardless of what state we're in thing that just tries everything and, does a bunch of checks. And here we're obviously missing checks because,
But would it help if you just had a single queue? And would you just postpone this event, or just put it in the end of the queue? If you say, I'm not ready yet, I just push this event back in the very end.
You mean like treat this like an event?
Yeah, something like that, yeah.
But I think that would be a lot of restructuring because right now, this is a method call that actually mutates state, right? And it uses these locks. So every single one of these receive routine calls, where are we? Right. So every single one of these, like this and this and this and this, actually goes and executes something, and grabs the lock and then mutates the internal state somehow. Either adds a vote or adds a block or changes the step or whatever it might be. So we don't really have a single queue of like transitions to take, which would be a lot nicer for sure. And that's kind of along the lines of the refactoring we want to get to.
Okay.
It seems like maybe we have even more problem here because while we are in this period where timeout commit hasn't expired or hasn't passed, all those transitions here might not be correct, not just handle TX available. So what if you receive a message like, should I react on the message if I'm kind of not yet ready? Or
well, it depends on what you received, right? So I mean, we could, so either you're receiving a proposal or a block part or a vote. Those are really the only things you can receive here, right? Mm-hmm. And so we can see what happens in each case. So if it's a vote, that's the whole point of being in timeout commit is to receive more votes. And we know that.
For the previous instance.
Yeah. Yeah. But we're not, our peers know where we're at. So they know we're not ready to receive votes for the next time. So if they're sending us those votes, then, something's either wrong at the gossip layer or they're malicious, right? And so they'll wait to hear from us. Oh, now we're at the new round in the new height. Now you can send us, the new votes, right? And same with these, right? So if we receive these for the new height, it's our peers acting maliciously. Unless we've done something wrong at the gossip layer with the update there, right? Because they're not supposed to send us stuff until we tell them we're ready.
Okay. Yeah.
Now, proving that that's the case is a whole nother matter of reasoning through this code, but yeah.
Yeah, but this might be the reason why actually we need to sort of mutate the state, so this logic could actually be able to fill the pre-commit from the previous height.
Yes.
Because triad vote actually assume that we move to the next height and we are now collecting the pre-commit from the previous.
That's right. Because you're now going to be in a position where you're adding a vote for previous height. So this add vote, right? So this is it. This the comment even tells you. Things are so annoying. There we go. Right. So we're in timeout commit. We've already increased our height, right? And so now it's for the previous commit. And so now we can add the vote there, right? The block's already been executed. We're already good to go. Now we're just accumulating votes for the last commit. Yeah. So where does that leave us with respect to this? As you know, I don't think any of the options are particularly nice. I mean, it's another signal that we need a larger refactor, but in the scheme of things, I think it might be, it might be better here to have more mutable state than to have another timeout, but I'm not 100%. I don't love the fact that, the timeout commit stuff is just like scattered all over. But one way or another, we're going to have conditions here related to timeout commit. So it's a matter of if we want to trigger more asynchronous timeouts, or if we just want to mutate some state. We're already holding the lock. So, we can set some Boolean, and then, This thing has caused us no end of troubles, eh? This whole mempool consensus interaction thing. It's been, every few months there's another problem with the empty blocks. And this one's, it's not fatal or anything. It's just unexpected, but.
Yeah, but this is interesting one. It's really interesting one because it affects it has consequences on a upper business logic. So because of this, some validators which are behaving normally will sort of be punished because they are not they are like kind of not available because their commit messages might be a bit delayed.
Yeah.
So it kind of would negatively affect their business. So it's kind of also interesting use case.
Now, do we know, was this only happening on a single node testnet? Did he tell us?
I tested it on a single node.
So on a single node, I would expect it to be very easy to reproduce. But with many nodes, I think it would be harder. And the reason for that is because on a single node, you move through the whole consensus sequence without yielding to the scheduler again. Whereas with if you have multiple validators, you have to continue to yield, which means you give opportunity for more transactions to be accumulated. Anyway, I mean, it doesn't excuse the fact that, there's some kind of bug here, but it just mitigates a bit. So anyway, so what do we think? We should try this again with using some new Boolean.
I don't understand why Boolean is better than scheduling like a round step new round timeout.
It just seems like there's more to think about here.
It might be just kind of more easy to read, but I think that both are somehow equally bad. I mean, we were having issues. We were having. You remember the story with the flag for
the other flag,
yeah. And so we kind of that flag was the shared state, and it was also calling us issues. So I mean, with also these timeouts, we also had issues. So I think we have examples of issues on both sides. So we can't say that one is better than the other. Maybe just the logic might be simpler if it's a variable, so we can explain what it means. And then when you read this kind of TX, it will be, okay, this flag is now true, something like this. But
right. It was this guy, right? The triggered timeout commit that we had issues with before.
So there's also a second PR that the guy who opened the issue made a PR to solve the issue.
Really? Did he link it? This one?
Yeah, what he did is he modified mempool to wait until timeout commit.
Oh no! I think the thing is that we'll have essentially the flag which says we kind of started height, but we haven't really ready to go. And then the TX, when the transaction arrived, because we only triggered transaction this thing for the first transaction in every height. So we need essentially to remember this and say there was a transaction.
Yeah, so it'd be something like, you know, transactions available in here.
Yeah, exactly. Yeah, but we might need one more variable. But
no, we can get that from the existing state.
Okay. Yeah. So then tx available is set to true once once mempool triggers, and then in this handle tx available, you will probably need to check this or.
Yeah. So it'd be like we're waiting the timeout commit. So how exactly do we check that? We'd have to see that we're at the new height, but we haven't started the new round, I guess.
No, I guess here with handle tx available, it might be just setting this flag, but then at other part of the code.
Then we have to reset it.
We need to reset. You're right. Yeah.
So in update to state, we would have to reset it, and then we could you know, cs dot tx is available false.
I'm taking off my opinion that it's simpler like this.
What's that?
I'm taking off my opinion that it might be simpler like this. So
with the mutable flag.
Yeah.
Yeah. So maybe we should just use the timeout.
Yeah.
Okay. So this is basically saying.
I think we should seriously consider writing this properly.
Oh, we need to. We have many open issues, but it's a complete refactor of the whole state machine.
Yeah. I mean, it's not like that we'll consider it. I mean, there's definitely it's one-way street, and we know this for a long time. It's just we need also to live in the meantime with this until we rewrite it. So.
Yeah.
I have a kind of like more general question about like single node bugs. Is that something that we should care or not? I mean, what's the general feeling there?
I don't think this is only a single node bug. But I do think
about another one actually that it's still kind of open there. You said, should we close it? And yeah,
I think we do want to support the single node case. You know, it seems less important, like less critical, less mission critical. Yeah. But I think it's still important, you know, that people do a lot of testing on single nodes, and they shouldn't have unexpected behavior, right?
Okay.
That was a big issue with like with the priv validator, right? This comes up all the time because the behavior is quite different if you're a single node and if you're on a network, right? Yeah. You got a lot more resilience. If there's many of you, it's easier to recover and so on. Whereas a single node, you kind of, you know, stop the world. And so, yeah, and then there's things like this that are more easy to reproduce as a single node and are probably still bugs, but harder to reproduce with many nodes because of the concurrency.
Yeah.
So.
Yeah. Okay. Yeah, we can like put it on hold, but in general, I think it would be then a kind of like interesting thing to take into account when doing the refactoring. So the next kind of redesign also takes into account like single node. Bugs.
Yeah. So basically, these are the same. So I would probably seek to consolidate this and this, and then the only exception would be to do this. And I don't think we need to reschedule the new height, right?
I have a question.
Right.
How is the so the last one where we enter around on else there?
Mm-hmm.
So that means the start time is after now. So this will be for the next height, the next TX available for the next height.
I don't think we should be using the start time here. I think we should actually check the state, something about the step. Like we need to check that we're actually waiting in the timeout commit phase, because this is too racy probably. I would think.
Okay.
It might be fine, like because of this, because this will happen anyway. But okay, I think don't think we need this. And can we more concretely assert that we're in the timeout commit phase here using the state other time, and we consolidate this with the execution.
No, I thought about it. If you have ideas, then sure. Like I thought about it, but I didn't find a way. I haven't found a good way.
Well, I think it would just be, you know, if this and
like
not
this skip timeout commit should always go first. Because if we configure to skip timeout commit independently of whatever we're waiting or not or whatever, yeah, we should just go to the next slide.
Sure.
If we have all the votes. If we don't, then we again check.
But this only matters if we're in that phase, right? Like this only matters if we're waiting, if we're in the timeout commit period.
Right.
So that we should be starting. First thing we should check is if we're in the timeout commit period. If so, and this stuff is true, you know, then go to the next round. Otherwise, if so, and this stuff is not true, then schedule the round timeout, and then otherwise go to the round, right? That's basically what we're saying. So if we're not in the timeout commit period, we can go right away. If we are, and this stuff is true, then we can go right away. But if this stuff is not true, then we have to schedule the round timeout.
But if we are in a round time period and we see new transaction, we shouldn't immediately go to the new round.
If what?
If we are in a timeout commit phase and we have we saw that there is a transaction available.
Yeah. So if we're in the timeout commit phase and you know this stuff isn't true, so we want to wait it, you know, then we schedule the round timeout.
Okay.
Cool. So yeah, a few changes. Nice. All right. Thanks, team. So that was fun.
So yeah, a small hint for Igor, like that. You know, like one of the. I would say this is kind of a pretty standard issue we are having with the current architecture, and so the question is really like, it would be interesting to think if there is a way to sort of with this formal methods and new architecture, we are able to fix this before the runtime or production ready phase.
Yeah, I mean it looks scary, right? There is so much concurrency.
Yeah,
and it's not really about being distributed, right?
Exactly, but this is the point which we discussed several times, that we don't have so many issue on a kind of distributed side. There, I mean, we also had this kind of issue, but we have much more concurrency issues.
Mm-hmm.
So the
single node concurrency, yeah.
Single node concurrency, exactly. But
yes.
they are part with the protocol. Like the protocol here said, if timeout commit is not 0, you should wait before proceeding. Mm-hmm. And so this can be seen as a specification of the single node behavior, and to enforce it. So.
And even single node would be hard to verify if there is so much concurrency, right? We'll just have too many schedules even in a single node.
Yeah. Yeah. So I think we want to remove a lot of that because it shouldn't be that complex. I mean, we already did originally. You know, this is kind of the second iteration of the consensus state system. In the first iteration, we had a lot of concurrency, and we fixed it. And then we every function call happened in a Go routine. So any possible transition was just an independent Go routine, trying to lock the state and then do a bunch of checks and mutate it. And we collapsed all that into this, now everything's happening from that receive routine, right? So it's kind of more single threaded, and it can be played back deterministically, which is kind of nice, from the write ahead log, and that allows us to recover from crashes and so on. But we still have, inputs coming from different places, and the state transitions aren't as clearly laid out, and so it's harder to reason about, where and how things can change. So hopefully the next iteration will clean all that up as well.
Yeah, sure. The pseudocode looked much more sequential.
Yeah. Cool. Okay. Should we go to the next one? Well, I think for the next one, we were going to look at.
On the next one, we can either do Adita's, the rollback functionality.
Sure.
Yeah.
I'm a little nervous about this one, but let's do it.
So kind of some context. Some users have been asking for, like, when they're syncing a blockchain, then all of a sudden something goes wrong, they have to resync from square one instead of having to just roll back a block. And then also it would be beneficial for pruning. That's kind of like the context that I received.
Mm-hmm. So this is like administration, operator administration, like unsafe operations. There's a bug in your app, and so you hit that bug, and now Tendermint is like broken and can't move forward, which is expected behavior. But from a practical operational point of view, you've already synced 1 million blocks, and you don't want to start from scratch. You want to fix your app and continue where you left off, right? And so you need to roll back a block so you can continue. And so there's a bunch of background on this, and
but we don't support, right, like starting from particular state. Like, what if they revert the state to the correct version and then sync? That they would not.
Problem is, currently Tendermint has no way to throw away a block.
Okay.
So it will, and so if it executed a block and got to an invalid execution, there's no way to recover from that by changing things at the application layer. You really want Tendermint to like undo the last changes it made to its internal state, right? But this is going to be subtle because there's a bunch of different ways the thing can fail. And so, we'll see what he did here. But so let's not start here. There's a test. What do we got? Delete stuff, lots of deleting. Here's a store, revert block. Block equality. Okay. So there's actually, was there a command line thing here? So I think he's just implementing the functionality first. So it's not 100% where this is going to be called from. Am I missing something?
He left it as work in progress, so
okay.
the command isn't implemented yet.
Mm-hmm.
I think he's waiting on some feedback to fully implement it, but he's also working on modular anti-handlers on the SDK.
On the SDK, sure.
And he's one of the review PRs is he's writing a spec for the IVL tree. If we want to review that as well, it's also like work in progress. He told me he just needs to add the proofs, and then the spec is more or less finished.
But in this case, if you revert a block, then you are creating the essentially the misbehavior proofs by creating another block. So it requires synchronization at the level of the whole network that all nodes.
Yeah, this is incredibly dangerous.
So I'm not sure really that we want to do this because.
Well, people need a way to do this for development purposes. So either one way or another, the functionality is gonna need to exist so that people can deal with bugs in their apps. It should obviously be behind some kind of unsafe flag or only available in the developer mode from a command line perspective. But
why there is no way to do like snapshots and configure the period of the snapshot? And then, I mean, if it's for the developer, I mean, is it going to use too much memory? Or
no, we want that kind of feature, but this is specifically where like the developer screwed up the application. And so, the latest block that Tendermint committed, when it tried to run it against the application, it left things in a corrupt state. Yeah. Because Tendermint panicked because it got something invalid, and it's like, that's the developer's problem. And so currently the only way to deal with that is to restart the whole network, right? And what we're saying is we want some way for Tendermint to be able to roll back. It could roll back to a snapshot, or it could just roll back one block. Here we're just talking about rolling back one block. So obviously that's super dangerous because when the validator makes the next block, suddenly you have evidence of misbehavior.
Yeah.
But, from a
what I mean, if it's for actually a developer and he has control over the whole network, and probably a network is like 4 nodes. I mean, you just have a snapshot every block or every 5 blocks or whatever, and just like as you say, I see this as so dangerous that if the problem is developers, it's like, you really want to do something like this. It's like,
well, how do you provide them the ability to roll things back? One way or another, you're creating the danger. Like if you can roll back, unless you force them to change the chain ID or something, but that's going to be a lot more work on us to make it sync across chain IDs.
But Bucky, in this case, can you just understand a bit more context? Like there was issue with the application, but we still committed. So Tendermint committed the wrong state, or Tendermint hasn't even committed the wrong state.
Yeah, so Tendermint committed the block, and then let's see. So Tendermint commits the block, and then tries to go away, and then goes here, apply block, right? And something goes wrong. And so this is the only place it's interacting with the app. So that should be fine. So Tendermint will kill itself. Yeah, unless it fails to kill itself, but typically it succeeds to kill itself. And so
but the block is committed, but it's not it's not really executed against the application. Mm-hmm. Mm-hmm. So why you just not modify application and you restart, so you will replay the last block, and then you do something in the application.
It's a really good point.
Especially if you need the synchronization at the level of the whole network, and you can do whatever you want. Like you can say, okay, once we now start, we'll change completely our state, and we'll set our state to X, and not we'll ignore the content of the block, and we'll change the state to X. And then
can you commit another block that kind of nullifies the result of this corrupted block?
Exactly, or do that.
I think it's the problem is maybe the off by one issue because the app hash came from the previous block. So if there's a problem at the app, right? If we so the issue could actually happen earlier, where the block has already been committed, and the app hash is wrong. And so you have a non-deterministic app hash, right? And so everyone committed block height 10, but then it's impossible to get, and at block height 10, half the network computes app hash A and half the network computes app hash B. And then it's not until when they try to come to consensus on block height 11 that they discover that they can't get consensus because they disagree over the app hash, right? So the panic will actually happen earlier. It'll happen it'll happen when you try to validate the block. It'll happen here after when you go to try to pre-vote, and then you'll just be stuck. Everyone will be stuck. Well, half the network will vote on it and the other half won't, and you'll never be able to move forward because everyone, the last block has already been committed and executed against the app, And so, but I guess the app should be able to just say, well, I haven't executed it yet, so try to re-execute it and then give me a new app state, a new app hash. But Tendermint already has it, so Tendermint needs to be able to overwrite it. Otherwise, let's see.
Yeah, this is different thing. So we are essentially we want to let them override the state, so Tendermint internal state where the application is reflected, but not modifying the blockchain itself.
Yeah, so this would fail.
Yeah.
Right.
So if this
we'd have to. So it should be a simpler thing to just allow this to be overwritten, right?
Exactly.
Like,
so you essentially
allow this.
Exactly. So essentially, in that case, you would probably want to put the application in the right state. So they need to find a social consensus. What is the right state? And then when we start Tendermint, ideally there is during init phase a way to override the application hash in the Tendermint state, and then it should go fine. But we should not revert blocks because I think this is too dangerous because and it's not really development. This is really issue in production system. In development, if you have a problem, I mean, just reset the network. So. Like I don't buy this that it's development necessity. This feature.
Sorry, what? Say that again. Why isn't it a development feature?
I think it's requirement for production networks that once you mess up something, that you have a possibility to kind of continue. In development network, like just restart Tendermint, like there is no big deal.
Well, then you have to throw away your whole history, or you have to resync from scratch, and it's just takes time. I mean, that's a separate problem. We need state sync, right? But but you're right. Yeah, in production, you want some way to recover from bugs at the application as well. So it's really a matter of dealing with application bugs. But I think the fix is, unless we're missing something, it might be a lot simpler than. Yeah, so it's mostly about the app hash, and so. So why don't we link to that? Because it should only be the late. If it's only the and that is here. Oh no, it should be. Is that right? The store height is one ahead, I think. The store height is. This logic is always so complicated. No, not at 0. Edge cases. The store is equal to the state, but the app is behind. So I think it's this one. And then if we replay blocks, yeah, I think this stuff will fail. Yeah. Override the latest app hash stored by Tendermint. So seems we only need some way to let the app override the latest app hash stored by Tendermint rather than actually rolling an app. That sound right?
So guys, I'm a bit lost here. So the block in the Tendermint block in the store may have the wrong app hash though, right?
No, the Tendermint block we're assuming the Tendermint block in the store is correct. But the app hash that was computed from it, which it hasn't been included in a block yet, it'll go in the next block, but it's stored in the Tendermint state, is wrong.
So can we just restart the current round?
Sorry.
So I remember seeing an issue very similar where on the Cosmos, on the Gaia network, where some new version of the app was released at a certain height, and I was restarting.
Yeah, so that was 34.6 to 34.7, and basically people were resyncing.
Yes.
And on 34.6, the miner changed a gas consumption. So when they were rerunning the transactions, a transaction that actually failed now passed because it needed less gas, and then that's when 34.7 was cut to solve that issue. So I think the solution that you're talking about also covers in the sense that if you're syncing a blockchain from zero, and then you all of a sudden you get the wrong app hash, and then you can, like in that case, you just roll back one block and then upgrade the version to 34.7 and then continue.
How would this proposal solve that rollback of one block? I don't know.
So in this case, like when people ran into the issue, they first had to message us to see what the problem was, and then we debugged it. Bez found the issue, and then we released 34.7, and then basically people had to start from zero, from block zero, and resync the whole blockchain instead of starting.
But the idea is the solution that
I think this solution would make it so
something that
if it.
The idea here is that only the app has to roll back one height, not Tendermint, because Tendermint, assuming Tendermint has the latest block in Tendermint is correct, but the app hash that results from that block, which isn't included in the block itself, it'll go in the next block, is wrong. And so Tendermint has correct blocks, the last block is correct, but the app hash it's saved in its state is wrong. And so then the app will need to roll back one height, and then everything restarts, and then Tendermint will replay the latest block, and then the app has been upgraded, so it'll now return the correct app hash. But now Tendermint's going to compare the app hash it just received from the app with the one it has in the state, and there's going to be a mismatch. And so all we need is a way to say, hey, overwrite what you have in the state with the new thing that was returned from the app. And then we can continue.
And also this is nice because it, unless...
But one second. But I think there's a scenario where Tendermint has a wrong app hash in the latest block.
It's possible. Let's try to figure that out.
Exactly. So that's, I think that one of the sources for this PR was a case where that happened, right?
But is that, I'm not sure that can happen unless everyone has it incorrect. Because you can only get, like an app hash only gets included, it only ends up in a block if the block gets committed. And so unless the whole network, or at least 2/3 of the network, has computed the wrong app hash, a block with an incorrect app hash can't get committed, right? That would be an invalid block.
Yeah, but like you can commit something which doesn't make sense from the application point of view, and like you can do it consistently. Like the whole network is actually doing something wrong. And then
yeah, if the whole network's doing something wrong, that's another story. But that doesn't seem to be the issue, right? mean, maybe that's a separate issue we need to treat, but it's not clear that what we're talking about isn't sufficient.
I'm just wondering here regarding this case we're talking right now. In case we roll back the application state for one height, and then we essentially replay the last block. I guess one thing we need to care about is the syncing, because now the application has been modified. And if the new application is not compatible with the previous one with respect to the previous block, by syncing, you might end up with the wrong state, if I'm not wrong. So ideally, in this case, like the application will be having I don't know, maybe a new version. So and then you would use new version for up to block H, and then new version after block H, something like this. If they're not compatible, but it's somehow to application developer. So I don't know.
What's the issue number, Marco, again? The one you were mentioning earlier?
This one, 3845, or the Gaia one?
Gaia one.
Oh, the Gaia one, I would have to go look. I just remember this scenario where people were saying this issue, and then I remember Bez going and debugging it. I actually don't know if there's an actual issue to it. I can search for it.
But do we have like a versioning of the application? I think that like, does it apply in this case because you are modifying the application, so it should have a different version? I haven't implemented this yet.
Yeah, I don't think that's well implemented yet. I think there might be a field for it somewhere, but it's not really used or propagated or anything. Yeah, one of the things we struggled with was, like, you know, if you include that in the node info, but you upgrade your application while you're still connected to peers, how do you then tell your peers that your node info has been updated? It's kind of a, you know, just a edge case consideration of, you know, the validity of the node info. It would become stale. So we kind of never fully worked through that.
But this is I think a kind of interesting case, and it might require a bit more thinking that we try to address this. And I think the example from the Gaia is also a valid use case, and so, like, it would be nice to have a way to properly deal with this without requiring to start Metro from scratch.
Mm-hmm.
Because if it's really only about the last state and essentially the chain is blocked, so there is no risk of, like, you're anyway blocked, and so now let's try to have a mechanism to do it. A nice thing is also that it can be done asynchronously, like.
So if you roll back by one height, you have this locked value in consensus, right? Does it also kind of, do you have to forget it?
Yeah, you would be throwing away the whole height, anything from that height, which means you're going to create a ton of evidence of misbehavior. Like, everyone who then signs is going to do probably something incorrect. But, you know, that's the issue here. Yeah. So I'm going to post this. Is there anything wrong with this?
And this looks good to me.
Cool. All right. Dev session review. In-house. In session. Okay, what else?
So the next couple is the spec, kind of like the resurrection of the spec repo. And then the other two are the spec in IAVL and the pruning PR in IAVL, if we want to review those on the call.
Sure. The spec repo stuff? Yeah. Let me pull that up again. Let me just
It's just like if we're fine with the structure, and then and if we're fine with what it says in the READMEs and the RFC template, and then we can merge that and then slowly start transitioning the specs over. And then if we have any PDF versions of the papers we've most recently posted and posted in the past, then we can include that in the paper section and so on.
Cool. So starting with spec poll 48 oh yeah, and the IVL stuff. I don't know if we can really do the IVL spec. I guess we could work through that. Maybe we'll save that for another one, or for maybe when Aditya wants to join the call or something. In general, I would prefer for reviews to happen while the authors are present. I think that would be more constructive. But so we could look at. So the only other one then is the resurrection. Is that right?
Yeah.
And this is just a total restructuring of the spec repo.
Yeah.
So is this something to review live here? I mean, we're not really reviewing content, just organization. So I don't know that.
Yeah, I don't think
there's anything really to discuss.
Yeah, just if everyone's just kind of more call for people to just quickly go look over it.
You're just reorganizing the current repo, and
yeah.
It's just a reorg of the current repo, and then we'll bring everything else over, right?
Where is the proposal? Sorry.
It's Tendermint /spec, and then poll 48. Yeah.
Yeah, other than that, I guess we can also stop recording since if we're not going to review anything anymore.
Yeah, stop recording.
Or we can do the Amino PR. We can start the Amino PR.
Who wrote that?
Ismail.
So he's not here. Anyone else got a PR that they want reviewed? All right, I'm going to stop the recording.